So in this example, we're given I and j relative to the origin, which is O, and then we're trying to find the other vectors to the different points here, so D, A, B, and C. So if we have a look, the first question here says, using the vectors I and j, give the following vectors, O to A. So if I draw, I'll do this with an arrow, O to A, oops, this would be O to A, like that. And so what we want to try and do is to draw that using the I, J, and K. So you can see we'd go across this far in the I direction, so that would be 2I, and then we'd go up this way. Remember, we always add vectors head to tail, so we'd have 3J. So if we wanted to write down our answer for that for A, you can see that for the first example, O to A would be given by 2I plus 3J. Okay. The next one, we've got 2I, and we've got O to B. So again, we do the same kind of thing. I'm just going to erase these two and just drawing in O to B. So this time we're going that way. And you can see now you'd be going across in the I direction, up in the J direction. So you're going 1, 2, 3, 4 across in the I direction and 1 up in the J direction. Now you don't have to write the 1, you can just write the J. And remember that if you're happier writing it this way, you can also write these as 4I with the little tilde underneath and J like that. So you can put the little hat on the top, or you can put the little tilde underneath. They mean the same thing. The third one, O to C. So again, I'll just delete those pieces. So O to C is that vector. This time you can see you're going down in the I direction, in the J direction. So J is going up positive here, and it's just like with X and Y, the J is now a negative going this way. So you'd now have for O to C, you'd have negative 2J, because you can see 1, 2, and then across 1. And actually we'll put the I first. So we're going across 1 in the I direction, and then down 2 in the J direction. Last one is O to D. And you can see that for O to D, again, you're actually going backwards this time in the I direction. So that's O to D. Going back 2 in the I direction, and you're going up 3 in the J direction. So it would be negative 2I plus 3J, like that. Okay. For B, we can now move into using vectors I and J, give the following vectors. The first one is A to B. And I'll just erase this again. Oops. I'll do this in a different colour. So if we were looking for A to B, that would be this vector here. I'll get rid of this one too. And we can get there, we need to get from A to B. So we need to start at A. So I'm going to construct this now using, I'll use purple, starting from A. Now the easiest thing for us to do is to go back to the origin, because we already know the OA, this is going to be backwards, and then to head back up from the O to the B. So essentially what we're doing here, to get from A to B, we're going AO plus OB. And we already know, and I'll just do this in darker colour so you can see, we already know what A to O is. A to O is actually the reverse. We've gone O to A previously, we went that way. And if we want to go back the other way, it will be negative O to A. Because remember, when we turn a vector around, it's a negative in front of that. So this would actually be negative O to A, which we already know, and O to B, which we know as well. So we can put that in here now. So O to A is this vector, 2I plus 3J, and O to B is this vector here, 4I plus J. So we'd have negative 2I minus 3J plus 4I plus J. And that's going to be, when we're combining things, we're going to just combine the similar things. So, you know, your 2i's, your negative 2I and your plus 4I, so that would be 2I left over. And then negative 3J plus J, well, that would be negative J. Okay, and if you have a look at it, check it out, you can see, and I'll do this in a dark colour, from A to B is constructed with 1, 2, 2 down, okay, so that's the negative 2J part, and 2 across. So that's the 2i part. So remember with vectors, it doesn't have to start at the origin. You're basically just looking at constructing vectors using these size vectors in these directions. So these are unit vectors. Remember they're a length of 1. Using those vectors to construct triangles that get you from the tail of the vector to the head of the vector. Okay, so we can use a similar idea now to do B to C as well, and without having to go back to the origin. So I'll just erase these parts. Okay, so this time we want B to C. That's B to C there. And we can actually do this now, understanding that relationship between the I's and the J's and what we can do on this diagram. We can just draw ourselves a vector like that. So you can see that for B to C, so this is for part 2, that was part 1. Part 2, B to C would be given by 1, 2, 3, so 3 going down in the J direction, so that would be a negative 3J. And then also going this way in the I direction, that's backwards, 1, 2, 3, negative 3 in the I direction as well. Okay, so that's BC, and that's AB and BC. Now the last part of this question here is asking us to find the magnitude of the vectors. So I'm just going to erase this top part now, because we've finished with that. And for magnitude, we're dealing here in 2 dimensions. So remember that for the magnitude of a vector, and let's just call the vector V, and actually I'll define it. So let's say V equals xi plus yj. Then we have the magnitude of V is given by the square root of x squared plus y squared. So for us, we're going to look at C part 1. We've got find the magnitude of AB, and that means finding the magnitude of this vector here, 2i minus 2j. So what we're going to do is take the part in front of the I and square that, the part in front of the j and square that. That's a negative 2. So when you square that, you'll actually end up having a positive number, so 4 for the first one and then plus 4, so it will be root 8, which simplified with surds is 2 times 4 inside the square root, so that will be 2 root 2. Okay, simplified. Cool. For the next one, or the last one, and again I'll just get rid of this section here, so we've got a bit of room. We've got for the second part, we need the magnitude of B to C, and we found B to C already, it's here. So we're going to find the magnitude of negative 3i minus 3j, which equals the square root of the part in front of the I squared and the part in front of the j squared. Both of those will turn into negatives, so we'll have the square root of 18, which is the square root of 9 times 2, which will be 3 root 2. So the magnitude of A to B is 2 root 2, the magnitude of B to C is 3 root 2.